Showing the line through this. Make sure you always keep that limit notation out there. At every step, make sure the limit notation.
This is justify your answer. If you just say like using the helper rules, is that like enough justification?
Yeah. Just make sure you mention the words using the candidates test for letter D. Just to find your answer. Yes, could you do the candidates test?
For C?
Oh, for C. I think it's just like mentioning using the Hospital's rule and stuff like that.
Did you get 3? Did you get 3?
Guys, focus on those reasonings because each one of them is a point to yeah, so set it up yourself.
Yeah, it's candidates. Like, I don't need to do it because I know -2 and 8 are maximums. And 2 is the only one that could be in the scope of
Guys, a lot of you in your limits, you're not writing down the limit notation. They're going to take points off if you keep doing that. So check if every step along the way you go to the limit x equals to 2.
It's
Yeah. If you write equals,
you could put
notation.
I know, and then you have to use candidates because that's the that way. Absolutely. The value. They need the number.
Does it equal 0 as 6? As 6, does it equal 0?
Yeah, after. 0.
No,
Can you figure out where the relative minimums are, first of all? No, that's from positive to negative, that's maximum. From below to above, that's your only candidate for a minimum. So negative 2, 2, and 8 are gonna be your candidates.
Why would you test negative 2 and 8? Why didn't you put this in? Because that's the Why didn't you put this in?
You use that the first FTC.
But it's multiplied
The first
to zero.
FTC.
What about it?
You use f of 2 is equal to 1, create a equation for f of x. F of x is equal to f of 2 plus the integration from 2 to x of f of 2.
Where are you deriving this operation?
You use the first FTC so you can do the candidate test and you can
Yeah, and then, oh, it's 6 times after. I know, but it's not.
Wait, this is plus. What are the three test points? Negative 2, 2,
But it says
What did you get for
justify
the
your
equation?
answer, that's kind of what they want you to, you know,
You said
show them that the
What's
left
the
hand
equation?
is like this,
I
the
thought
right hand
2
is
plus
like
the
F of
integration.
x is equal to f integration of 2
No,
to
you
x
showed
of
the
f
candidate
derivative.
test, right?
But how
So you're showing negative 2,
Negative 2.
and then show 2, why don't you do the endpoints?
So I should do negative 2, 8,
Yeah.
and 2, but not negative 1 or 6, right?
Yeah, because those are
Sure.
relative
What are the-
maximums or neither, so what's the purpose?
No, you have to test negative 2 and a 2.
Oh yeah, I know that. But how do you know the original function is? Do I have to draw a graph? F of x is equal to.
But because here it shows and here it shows they're all
How do you know the function I used to do the integral? Second. Yeah, but how do you know the second? Well, actually, we're not talking about this one. You're trying to. The interval.
It's good that you 1 minus, but
You're only gonna get a point out of 2, you're gonna write down
So
the
it would be
percentage
f of
that
x.
says that.
Oh. So we're using first f of x.
Give a reason for your answer. You take
Plus.
the practice, take it seriously, like, you write it down.
Plus 1, and then.
Sorry if you're a little bit behind.
I don't think it's right. How do you know if you choose f? Because that's the initial condition. I know it's f plus whatever you put
Is it?
in this one.
Yo, what'd you get for the absolute negative 3?
no, it's 2 1 minus. Where did you get negative 3?
No, the absolute, not the x,
The absolute, oh, the value.
the absolute.
The value of the absolute min is 1.
1 minus.
Yeah, which is
2. Test all the points and
C
see.
plus negative 2.
Yeah, if it's a negative 2. I got 3.
I got negative 2.
I should get negative 2. Okay.
You tested f of negative 2. Did you get
It's 3, it's not negative 2. The negative 2, I got 3.
So, it's gotta be from.
1 minus negative 2 is equal
The
to 3.
absolute minimum is 2, right?
Those cancel.
Did you get 1 for the f of x?
I mean, I just wrote the format for you now, it's your job.
Yeah, I got 1.
Thanks for yourself.
1 half. Oh yeah, so the first one is negative 2.
Let's take a few more minutes, and we're gonna start grading ourselves.
Because those two triangles cross each other off the diagonal. Oh, and you just take the area of
Okay.
both.
Yep.
It's 1 minus negative 2, so it's 3.
No, that means you're gonna be taking the area of
Sorry,
that.
that was my own.
Plus.
So when I take the area of two, I'm gonna do solve for that one triangle.
Yeah.
Yeah, it's more positive.
Okay, look. This, the original equation is from f of 2 plus the integration from 2 to x, right? Okay. Now we're gonna put this into that. Then we put it from x equals 2.
Okay, you see the two triangles that are diagonal to each other? Those are basically the same area, but one's positive, one's negative, one's positive. Then the other triangle, on the x-axis, that's negative. So
You
two times
just
two
say
and
it's
a
more
half.
than the other one.
Negative two.
Now integrate minus 2. Eliminate
I got positive.
Now do 1 minus negative 2 times negative 2.
We're about to add. Wait, so negative one. Where, whatever question are you looking at? I got 1, plus 2 is equal to 3. Because if you're reversing, you need to add the 2's gonna be right? Remember, because it's going, like yesterday, it's going from 2 to negative 2, it should be switched, it should be go from negative 2 to 2.
But then the original, the area is already negative, right? So the negative.
Exactly. So it becomes 1 minus negative 2, and then when you equal, it's 3. So the absolute min is at, 2. Wait, so is negative 2? Oh, I just remembered. You don't have to do all of them, because you know that it's all positive. All of this is going to be a big number.
And you want the small.
This part and this part cross out.
So that was the area of that part.
You know that
You
one.
still need this part,
I
right?
probably And might that not. area is
So yeah,
It's negative 2.
Wait, brother Hosses, I have a question. When you know that like an area is already gonna be more positive,
He was asking the same thing, I think play it safe and actually tell them what it
Well,
is. Cause I feel like when they say justify your answer, they're kind of twisting your arm a little bit. We'll take a look at it.
so I got 11 minus 2 5.
11 minus 2, 5.
Because it says, unsatisfied, 2.
Yusuf, I got that.
Okay,
I got that.
time to grade. Okay. Alright. What number is this? 4? Alright, listen, let's get started. Guys, now don't go back and change any answers, okay? Be critical of yourself. Alright, let's start with the first one. First of all, it was a derivative graph. It looks like everybody understands it's a derivative graph. Nobody mistook it for anything different than that. So this question is going to have 1 point to it only.
Okay.
And you're gonna say that f derivative does not change sign at x equals 6, so there is neither a relative max or a relative min at this location.
What if you said it's a value because on the f derivative graph it doesn't switch sign?
It says that a scored note, a response that declares after it does not change signs at x equals 6, so neither is sufficient.
Yeah, you know, these notes are obviously there
Oh.
for both of us to look at. You know, this one's kind of tricky. Be careful with this. It says a response that declares that the derivative was positive before and after. I think one of you, I walked over and I looked at you, kind of said something to me like this, but it says you're not going to get the point if you say that. Okay.
Like if it's positive before, positive after.
Yeah, you have to explicitly, that's very tricky. You have to explicitly say that it does not change sign at 6. Okay? So. That's not, wow, that's actually, I was surprised. I would have said that was okay, so, alright.
Well, also if you do see that, you just hold it.
I mean, now I can't, be cheating you and cheating myself. Okay, let's go to letter B. This one's gonna be 2 points, okay? First, let's just kind of read the stuff and then we'll, ask your questions. You should have said the graph of f is concave down on these 2 intervals. Notice how they're both open. You guys have asked me multiple times, open or closed, they're open. Because f derivative is decreasing on these intervals, I believe if you say the second derivative is negative, it should still give you the same points, okay? If you got the intervals and you said nothing else, then you give yourself a point. If you have the reasoning, then you give yourself the second point. can't get, so some questions, you can get the second point without getting the first point. They don't double dot you for it. In this one, it says that response must earn the first to be eligible for the second. So this is not one of those scenarios where even if whatever you said on the first, you just made it up in the second one. You must correctly discuss the behavior of f derivative or the slopes of f derivative. A response that presents exactly one of the two correct intervals with the correct reasoning earns 1 out of 2 points. So guys, let's update a few things. Did you all write down that f double derivative is negative? Is that what you,
I said the F.
No, I said after
slope
this
is
dp.
negative.
Can you write down that now, you know, again, this is more recent, but they're giving more priority to you saying something about the slope. So write down f derivative is decreasing.
Wait, so you can't say F derivative slope.
You know,
is negative?
again, look, it's not written anywhere here, you know. So in my teacher notes from back when I graded, they were okay with it, but we'll take a look at some student responses to get on the bottom of that, okay? It might also be in the notes for graders. I'll take a look at that. Yes?
What if you didn't write up to the point where they start talking about the integrals? Like, I didn't write the graph at first calculating down now. I just wrote the integrals and then the reason why.
You're good, no worries. As long as you wrote down the intervals and the reason, you're okay. Okay,
Did you talk about the F in the second derivative? Is that what you did?
again, it says to earn a second point, a response must correctly discuss the behavior of f derivative or the slopes of f derivative. And so to say the second derivative is negative, I don't think you're explicitly referring to what's happening to the f derivative necessarily. Yeah, that's a tough one.
So then when we do derivative tests, then you can't talk about the second derivative.
Yeah. That didn't used to be the case, but I'll read the teacher notes. Give me a minute. Okay, let's go to the, was there another question?
No.
Okay, let's go to letter C. Now, I've been on your case for a while now about these, okay, so let's see how well you did. This used to never be on the free response, first of all, okay, it used to be a 1 point thing. Limits of numerator and the denominator. Okay, so take a look at how they wrote out the limits. They explicitly went out and they said everything like that. And they said that both of them are equal to 0. I do not believe that you need to define continuity at the top in order for you to start doing this. Go take a look at the notes. Then it says using L'Hopital's rule. Take a look at, they said because this thing is indeterminate, 0 over 0, we're gonna use L'Hopital's rule, and then they will go ahead and do it, and then they get to an answer. So 1, 1, and 1. Now, let's take a look at the scoring notes here. The first point is earned by the presentation of 2 separate limits. Okay. Yeah, 2 separate limits. So from here, again, I sometimes start simple with you guys in the beginning of the year, and then I start to tell you, look, we need to polish this off a little bit, all right? So from here on out, you're gonna write separate limits for the top, and then separately for the bottom. It says a response that presents a limit explicitly equal to 0 over 0. Have we discussed this before?
Yeah.
So we are already not doing that anymore. The second point is earned by applying L'Hopital's rule, that is by presenting at least one correct derivative in the limit of ratio of derivatives. Basically what they're saying is this part right here, we will only judge you by either you taking a derivative correctly of the top, or I think of just the bottom, just to say that I'm gonna use L'Hopital's, okay? And to show that you understand what that means. Give me 1 second, guys. The third point is earned for the correct answer with the supporting work, as you can see. Yes, please.
So like, would it be safer to just put the arrow, or is it okay if you put quotation mark over the?
Well, according to what it says over here, Hadis, you should do them separately like this
No,
time.
I'm saying like, cause you know how like we can't say it equals 0 over 0?
Yeah.
Is it okay if you just put the quotation marks with the equal
Yeah,
sign?
yeah. Now, take a look at this candidates test, alright? First of all, did you guys consider negative, 1, 2, and 6 to be where the derivative equals 0?
Yeah.
Okay, so to consider those, not those points, but to write down f derivative equals 0 at, and then write those points down.
We also, so we don't have to test 91
Give me a minute, okay? And then the justification and the answer would be, I believe that, right over here.
So we would have to account for 2 and 6.
Give me a minute, okay? There's a lot of notes to this, okay? It says to earn the first point, a response must state f derivative is equal to 0 or equivalent. Listing the zeros of f derivative is not sufficient. Okay, so write down the f derivative equals 0 at this, this, and this. Again, now is not a point to get frustrated, now is a point to correct yourself and be like, okay, let me fix these things. A response that presents any error in evaluating f at any critical point or endpoint will not earn the justification point. So it sounds like the justification are these guys over here, the candidates. A response need not present the value of f of -1, provided x equals -1 is eliminated because it is the location of a local maximum. Have I said that to you before?
Yeah.
Okay, so back to Yusuf's question here. A response need not present the value of f of 6, provided x equals 6 is eliminated by reference to part A or eliminated through analysis. Now, Yusuf, you've asked me this, and someone, I think Jenna asked me this. A response need not present the value of f of 8 if you said this, provided there is a presentation that argues that the derivative being positive means it's going to be an increasing function, and therefore the f of 8 would have to be greater than the f of 2. If you say that in some sort of way, then they will give you the point. You don't have to explicitly tell us what that is actually going to equal. And finally, the answer point is earned only for indicating that the minimum value is 1. It is not earned for noting that the minimum occurs at x equals 2. That's super annoying, but you need to tell us what the value is because they asked you what is the value. They didn't say where does it occur at. Safest bet, just write both. Okay. All right, now what I really want to do though is I want to look at an answer of a student who got all of them correct. Okay. So take a look at yours. All right, take a look at this. And just kind of see how are you aligning with the perfect score. That's all. All right, it's not the month of May, so don't get too worried about it. I think I walked around, I saw most people were good with this one, and move on. That was fluctuating. Alright, we've made this kind of an update, so f derivative is decreasing is still the more preferred way of them saying that something is concaved out.
So is that the same way of saying like f derivative of the slope is negative?
Yes, you can say that.
Oh,
That is
okay.
accepted. That is accepted.
We don't have to mention that f derivative is decreasing.
If you said that the slope of f derivative is negative, that's acceptable. What I was saying is to say the second derivative is negative, because it's not explicitly telling you something about the first derivative on that paper, they're not okay with it, okay? At least so far. Okay, now let's take a look at this one over here. It looks like the student has explicitly written the top and the bottom and showed that they're 0, and then they went ahead and said that we're gonna go ahead and use the L'Hopital's rule, and then they used it. Please make sure you put that limit in to the problem when you're doing it. I know for a fact if you keep leaving the limits out, then they're gonna mark things off, okay? Did this student show all the candidates?
Yeah.
They did, but you guys saw in the rubric, it says you don't have to show all the candidates. And so this would be a perfect score, alright? So make sure you tell us where the derivative is equal to 0 and tell us all the candidates that would apply. And then you don't necessarily need to use -1 and 6 because those are locations of local maximums anyway.
Wait, so you don't have to show the work for those?
For -1
1 and
and
6.
6, no, and even 8,
If you explain.
if you tell us that that's gotta be greater than the f of 2, then I'm not showing it. Yes,
So if we explain that there's a maximum at -1 and 6, and that -2 is like above the positive derivative and 8, like whatever. If we explain all that, we don't have to say using the candidates as an explanation. We would just say that there's an absolute minute at these two to the value. If we like end up giving a
I
reason.
think I would accept that, but I'm more interested in knowing if the AP would accept it. Okay, I'm really interested because we do this a lot, right? We say f double derivative is negative, right? But notice how this person wrote down, because f derivative is decreasing, that's why f double derivative is negative. Okay, this is what I'm trying to explain to you. It's not like I'm telling you to stop saying f double derivative is negative. Just add that little statement to it that says f derivative is decreasing, and that's why I'm saying that the second derivative is negative. Okay. All right. Well, you guys have a good weekend, inshallah. Is the class at 9:30? Is it 3 or is it 28? Is it 33? Just hold on a tick. Don't pack up just yet. Okay, I again, we're trying to critique other students too, so be mean about this. What would you get marked
They
on?
put limit in the next step.
And they put is equals to 0 over 0.
Okay, easy catch. This person wrote equals 0, 0. So we're gonna take that point away from them. They do seem to have a final answer that's correct, but have they justified why they're gonna use L'Hopital? Alright, so I'm interested to know if they get that second point or not. But definitely they got 1 point here. I think Ola was saying something about this, right? So just take a moment and read what this person is trying to communicate.
They did it based off of looking on the class.
Well,
They do not justify that. They couldn't even bring up that.
I imagine I have to grade 100 of these in a day with Monday through Friday. It starts making sense after a second. Whoa, where are we going, man? It's talking about inflection points there.
Is that actually correct? I mean, it is.
Hey, this again, I keep scrolling for this. Here, they don't mention anything about f derivative decreasing or f derivative slope being negative. Listen, but they do write down f double derivative is negative, so I'm really interested. So just keep this in mind. This is student 3. This is 4B. We should go check now the work. Oh, what did they do here? They're not gonna get it. Might get something for that.
It's not negative 1, it's 1.
Oh, really? They didn't change that up? Okay. Okay, student 4A, we knew this person was gonna get a 9, okay? You got a 6, okay, 1 second. Part A. So they're good with part A, part B. They're good. Part C. The first point was not earned because the response does not present the limits of the numerator and denominator. So guys, make a quick turn here. From here on out, you're writing the limits separately for the numerator and the denominator.
So I'll write the limits of the numerator, I'll write the limit of the denominator, then I have to write a limit with both of them?
No, you just,
Separate.
separate.
Just put equals 0, equals 0.
And then when they one equals 0, the other one equals 0, then you put them on top of each other, and you put their
What am I gonna do in here? Just go ahead and not put 0.
Okay, let's keep moving. I don't remember what they did here. It says they got 1 point. The first point was earned with consideration of f derivative changing signs from negative to positive at 2. The response did not earn the second point because there is no analysis with the end points or the elimination of those interior points. The response is not eligible for the third point, so we don't even worry about the third point in this scenario. Okay, so Jenna's feeling bad for this person because they got a 2. So here's what I was trying to tell you. The second point was not earned because the reasoning is based solely on the second derivative being negative. That is quite brutal actually. They used to be okay with it before, so. Yeah, see, I don't think we were talking much about it. Since the first point was not earned because the response does not present the limits. Second point was not earned
He
because
said
the
he's not
ratio
getting
of derivatives.
anything.
Okay, they didn't read much there.
You got one in the bottom.
They got 1 point.
Wait, for what though?
Because they considered f derivative equals 0. They did
Oh,
have
that's
them.
what you do. Okay, that one was nice.
Okay, I think we all learned something today.
Yeah, separate the limits.
When you come back,
Our
next year,
derivatives.
we'll continue this.
Next
Alright.
year?